Good morning. Happy Wednesday. This week feels a little bit different because of that I guess it was scheduled the stream yesterday. But we're back on a normal schedule. So it's a good Wednesday morning. Hope you all are doing great. And we today are continuing with our Nature of Code Chapter 2. We've gotten into air and fluid resistance. So I read through this a little bit last night, and it looks like air and fluid resistance is very similar to friction, except it's a slightly different calculation. But other than that, it's going to be a force that gets applied in the same way. So we don't have to have apply fluid resistance. It's just going to be a apply force still. So I wanted to go through and it's starting to get a little bit enough complicated that I want to start getting into the habit of creating the checklist for ourselves. So basically, we want to set up the arena. Once we set up the arena, we're going to want a bunch of the balls. We want to create all the balls and have them fall and do the bouncing thing. So create balls. Create balls on the top of the screen. So let's see if balls fall. Balls bounce on the bottom. Balls have friction. So we still want the normal friction. Actually, you know what? Maybe we don't want the normal friction. We're only having the air resistance. So we're going to say no friction, because I think that's what we're having to do here, is that we're going to have no friction in the air. And then we're going to have fluid friction, fluid force, when it's moving through like a liquid. So balls bounce on the bottom, which means now we want to set up a create the ocean. So create the ocean, we want to give the ocean fluid dynamics, or like fluid resistance, I guess is the correct thing. Fluid dynamics is maybe a little bit more complicated thing. Once we give the ocean resistance, I can actually put these two next to each other. And it has, yeah, okay, so it has the, this is the, what is it called? The formula to calculate what the resistance is. So the resistance is going to be magnitude of mover squared times sort of like the coefficient of drag, which is just a random number we're going to create. And I think that's all we need. So when I run this, that's what we should be creating. I think this is enough. We'll discover if we need to add more, of course. So let's go ahead and get moving on this. I'm gonna first set up the arena. So I already created the new project, although it's completely new here. So cargo toml, we're gonna bring in GGEZ. Let's also rename this. So instead of fluid resistance, we're just going to call this fluid. So fluid there, that size is fine. Okay, so save that. Let's go create a main library. And nothing into here, and I think I can just immediately run this. Oh, we're bringing in thread range. I don't actually know if we need to bring this in anymore. I think I can probably remove this from the snippet that I'm using. So I'll run that, and let's go ahead and update our snippet at the same time. So it's not gmain, it's the glib. We don't need the prelude. We don't need you. We don't need you. Or you. Okay, so that should update there. I'm not necessarily sure there's any part of like this initial setup that we can do in the utility create. We might be able to create like a generator project, which would like generate this and maybe insert all this code to begin with. Then I wouldn't even have to use snippets. That would be interesting to see if anybody did that. Katali, hello, good morning. All right, so we have our empty base project working. So I can mark that as done. Next step, create the balls on the top of the screen. What are we talking about? Today we are working on air and fluid resistance from the nature of code. And so I created a bunch of sort of like a checklist because I think things are going to start getting a little bit more complicated with chapter 3. So I want to get in the habit of doing this now. And then hopefully it'll make it a little bit easier. And then I'm also trying to keep my eye on what are things that we could add to the utility crate that would make it a lot easier for us. Okay, but create the balls on the top of the screen. Well, we do have, I believe, we have the docs. What is it? Docs. So instead of GGEZ, I want GGEZ. So So what's the latest that we have in here? We have, right, just random bright color and random dark color. I believe, is this you, Katali? It's Katali, who is working on creating a mesh wrapper for circles. So maybe we'll have that next time. So we'll create the balls on the top of the screen. That's you, awesome. That'll be really nice to have. So let's see how I would use that. Down here, new file. We want our ball.rs. G player. So I'm gonna call this ball. We have this circle. It's almost finished, by the way. You just need to finish with some tests. Awesome. Hopefully won't end up using it in a weird way that requires, like, you know, a slight change, but such is reality. I'm really looking forward to using it. Okay, so we have draw mode, fill, point to, okay, right, because we're storing this this mesh into here. And it's just going into the 0 position. So I think this is fine. Make it a little bit wider. Okay, so that's all I really need to draw the ball out. So I'm gonna save. And we're going to now go back to main. No, not main, library. And let's create a vector of, let's bring that in. Okay, so we're gonna have balls, which is a vec of ball. Wait, you actually go up here. Okay, so let's create. Let's just start off with 10. Let's just see what happens if I try that. And then I'm going to balls.push. It's going to be a ball new. Okay, so we need a location to begin with. I'm thinking we know there's going to be down a little bit, but we do need random. So unfortunately, we do need that rand crate that I wasn't thinking we did. Now, I guess the other option here. Ooh, we can determine how many to do and then evenly space them out. So we're going to need the arena size. Specifically, we're going to need the arena width. It's going to be graphics, and that was drawable size. So that'll give us the arena width, and then how many circles do we want? Our circle count is going to be, let's say we do 10. We need circle size also. So I guess maybe ball count. Let's make the mass like 50.0 each. Just one question. Do you want that utility to be draw the circle directly or to create a circle mesh that you can assign to a variable and then draw it yourself? You know, that's a really interesting question. So I guess like on the one hand, it's draw So like I call a function on utility and it creates whatever draws down here in draw, or the other one is to store it. You know, I'm thinking right now, the way I've been using it is store the mesh in the entity object and then just draw it out to the screen, but that way I can change the location around. But the idea, that idea so far is the color stays the same. Although I think I can overwrite the color and do all sorts of other interesting things in draw. I think, and so I haven't talked to like Icefoxen, who created GGEZ. I haven't seen like what his like thoughts are on what meshes are really for. I think that they're for like do that around 0, 0. And then you move it with draw. So I think just the mesh. Crossbow, good morning. Okay, so new location. So this one, we know which one we're going to be in. So we do now need the index. Would it be index here? I guess we'll just call this count. And I want to have them spaced evenly across the top. We know the width, we know the number of them we're going to have. So the spacing is going to be, well, I guess just the width, the arena width divided by the number. So this needs to be a vector 2. So I need to add in vector 2s to my to here. So vector 2 new, the X. So this is going to be the arena. You'll try to do a PR this afternoon, this morning for you. Oh, awesome. If I get done early, I could review it. Unless, of course, I'm at work during that time. Okay, so balls push, vector 2 new. The X is going to be the count times. So is that what it would be? The count times. Oh, okay. The thing that we're going to multiply with is actually going to be the arena width divided by the size. So let, like the spread, the distance. So the arena width divided by ball mass. No, it would be ball count. I don't think the ball mass really matters for this. This is going to be it's going to need to be an F2, and so this is going to be our count times distance between. That's going to be the X, and then the Y is going to be, let's just say, like 100.0. Our mass color. So let's bring in our utility and we'll create a random color for it. I don't actually think I created a an auto. Did I? No, I haven't created anything for my library, so I have to go find it. pull that in. And so then we're going to say use bbggz utility. We need to create a new, so we need to store the utility. Random bright color. And then, of course, the context. You're upset. No implementation for... Wait, integer. Oh, you're... Okay, so we need... Can I just do as F32? There we go. Then in the game, we're going to store the balls and utility. Okay, so we get that. We don't need the arena height. So that creates them. We're not necessarily going to do anything with it right now. We just want to display it out. So in draw, we're going to do graphics. Oh, we have the for loop for it. For ball in, mute balls. Line 21. Ooh, I need to turn that on. And you're right, it does need to be mutable. Thank you. And I was a little bit late with the highlighter, but you reminded me, so I got that on for next time. Okay, so we're going to loop through the balls, and we're going to now draw the ball out. So, and let's see. Yeah, we're still drawing these to the screen. So graphics, draw, context, a reference to the ball dot mesh, and then the params, which is going to be the location. So that's going to be a point to from ball dot location. And I don't think we need anything else here. Then we present it. Let's see if I've got it. Well, it starts at 0, which means it's here. I need to offset this by the size. So when we create a new one, so the X is going to be count this, that. Then I want to add the mass, I guess the mass. So plus ball mass. And I need this to be a lot smaller, like 25. I'm going to guess I could even add that in, add that multiplied by 2. What? You're not resizable? I'm resizable there. Oh, I forgot to add resizable onto this thing, didn't I? So like dot, hold on, it's this one, I think. resizable true. So I need to add a resizable true to gmain. So here's this dot mode, so dot resizable true. And then what's the other? You can't, because if the ball's mass was bigger, it'd be out of the screen. Yeah, that is true. What if I multiplied it? So plus ball.mass. I don't think it's times 2. It might be times 1.5. There you go. I guess times 2 is perfect. So it's now perfectly centered in the screen up here. I could probably make this not as high. So I can start like at probably 50 down. Perfect. Now, of course, if I make this bigger, it's like initially set to be for like the half the size, but I'm fine with that. Okay, so we have the balls and they're displaying to the screen now. Now the balls fall with gravity, so we need to create a gravity for ourselves. So in our library, let's store gravity, which is going to be a vector2. So this is gonna be 0.0, and you know what? I've not remembered what it was that we've been using. So let's just say like 3.0. I should probably like actually note this down or put this into our what is it called? Snippets. Okay, so we have gravity is a force. We're just applying it here like this. And we can just apply the gravity into update here. Okay, so we're going to just say ball dot apply force self dot gravity and delta time. I guess that's just delta time. And then we'll update the ball. So I think this will make them fall. So they'll fall, of course, at the same exact speed. I think the other thing is that we do want to have slightly different size masses, don't we? So now that I think about that, so like ball, like ball count. Juan, good morning. I am creating a simulation of fluid resistance with a bunch of balls. or circles. So ball mass. You just finished a blog post? Awesome. Was it well, I'm in a Rust mindset, so immediately my mind goes to, was it about Rust? Yes, we are back to Rust. We're back to Rust and GGEZ. Node.js. Well, I mean that's a good language too. I work with Node.js professionally, so. Okay, so ball mass. We're at 25 right here. I don't think it's that, because if I want the ball mass to be random, then this is really just spacing. I just call this spacing. And just, I mean, this could just be a magic number of 50 for some unknown like reason. We do need to bring in rand. Let's go find crates. 072. And then in our main library. All right, so this will be bring in the prelude. I don't necessarily need like this multiple times, just right here when we create it. So we're going to create rand, and then for the ball.mass, we're going to then do rng.genRange between, let's say, like 10.0 and 25.0. We probably go to like 40.0. So if I do that, how does this look? I'm missing nim then. Yeah, I'm missing nim. You don't know if it's planned, but BBEG could be a wrapper on top of GGEZ. So using things like gravity borders, bouncing borders, resizable window, etc. Oh, that, you know, I hadn't even thought about that, Katali. That could definitely work. So I could basically not have to implement all those traits for update, and I just sort of say what we'd have to think about, like how we'd want to write our code then, because we could write it however we want. Oh, nim released 1.0 final. It's still a thing I haven't checked out. You should create the mass and variable so the spacing is correct. Yeah. So distance between, or wait. So right now this is just 50. So if I do this, well the mass, okay, so we're gonna let mass equals, then pull you up here, and you will be mass. And then you will be also mass times 2, I think, for the spacing. Let's see if we got the spacing a little bit better. No implementation for float integer. Right, 2.0. Truth be honest though, Juan, I'm probably not gonna get to nim because I'm too interested in Rust right now. How is the spacing on that? We could turn off the gravity. We could just make it not apply the force. Okay, so it's way off now. Nope. Just come on, move over to the left. You don't want to. Okay, fine. I'll manually move you. Gravity was inverted though? Gravity was going down, wasn't it? So maybe let's not multiply by 2. Let's just see what happens when I add the mass. So maybe plus like, I mean, I feel the spacing is a little bit odd. Oh, small balls were fat. Yeah, so we need to fix that. We actually never did that in the appropriate gravity section, so we can go back to the nature of code and take a look at what that calculation was supposed to be. So friction, gravity. Okay. So here's where it's supposed to be applied here. So scaling gravity to mass to be more accurate. So gravity is whatever we is multiplied by the mass. So we need to store the mass in the ball now. Well, we're already doing that. So gravity needs to be created here. So gravity can no longer be a vector 2. Now it's probably just going to be an F32, a scalar. And we'll just say that this is like something like 5.0. And down here in update, we apply the force, but we're going to have to say let gravity equals self that gravity. Wait, no, it's vector 2 new. Times ball dot mass. Then we just apply the gravity force. Oh, ball dot mass is private, so we need to make that public. All right, let's see if we're happy with this. Okay, so now I'll fall down at exactly the same rate. I'm not going to worry about the spacing too much. That's just, I'll have to figure out, like, I'll have to actually go in and like whiteboard out how I want it to look, and then I can figure out the math based upon that. Just trying to do it by ear is not working at all. Okay, so I have the balls. They're falling at the same speed. Let's now, they fall with gravity. Now we want them to bounce on the bottom. So in the ball, we want update, and then we want to bounce. We're going to need the arena size, specifically the arena. We just need the arena height, don't we? Which is an F32. And that's pretty much it. We're not going to update here. So then I'm going to Just gonna do that if statement. So this is an excellent one, like a bounce to like add in. I'd have to think about like how we want to use that. So if self dot location dot y. So if our y plus self dot mass, if that is greater than the arena height, self dot location dot y equals arena height minus self dot mass. All right, so that should bounce us. You're gonna go do some homework. Well, thanks for stopping by. Good luck with your homework. And we're gonna bounce in the main library. And so we need to get the arena. Oh, we have the arena size. Are we using this? Yeah, we're grabbing this here as arena size. This is really just going to be arena size .1. You'll try to think about the wrapper idea too. Yeah, that would be really interesting. If we can end up like pulling something off like that. Okay, so let's see if we got bouncing now. So we do. Interesting that they sort of like follow the different speed. The speed thing we know that we've had. We don't know exactly how to fix that, but the distance because the ball is because I actually make them hit at their bottoms. They have to, like, some of them have to fall further than the others. So that's a little bit interesting. Okay, so now bouncing off the bottom. We now need to create the ocean. So this is going to be interesting. We're going to have a brand new structure. We call this ocean. Okay, so what do we care about for this? All we know right now is it's going to be a mesh that takes up the bottom side of the screen, and then it's going to be colored like a really light blue. That's all we really care about. So we're going to have, I don't even know, do we need the mesh? We need the location. So location. You know, I wonder, is our rects, do rect have a public X and Y? Because if so, I could just use that. So I could do this. Use GGEasy rect. So I'm just going to pull in rect. Let me also do this trick that I've been learning about. Okay, so location is going to be a rectangle. We're going to have a color, but I'm going to put that into the mesh. So the mesh. Which means I also need the mesh builder. Okay, so we're going to store the mesh into the ocean. That's going to include the color too. And for right now, that's all we care about, is just drawing it out to the screen. Okay, so new. We want, I guess, a location, which was going to be a vector 2. We have, am I doing that wrong? It's not yelling at me. I just thought for some reason it was going to tell me autocomplete that for me. Okay, so we want the location, which is going to be a vector 2 of f32. We need the arena size so we can go all the way down to the bottom. You know, I kind of wonder if maybe I should just have this pass in. I could just have the location be a rect. That's what I should just do, is pass in the rectangle of the location. Oceans should know what color they are, so I'm going to have it create its own color, because that's never going to change. And I think that's going to be it. We're going to return an ocean. So that's... we need the color first, so that... So we have red, green, blue, and then the alpha. I'm thinking we're going to want a pretty strong alpha. So we want no red, no green, a light blue. So that's going to be something like 0.8, and then a fairly strong alpha. So 0.2. I think that's the direction I want to go. I might have to do like 0.9 with the alpha. So we create the color, and then we're going to create the mesh. So ocean, the location is just going to be in there, and then the mesh. So mesh builder. This is messy enough. I want to pull it up here. So dot rectangle, we need draw mode. Okay, draw mode fill. The bounds are going to be the rect, so that's going to be the location. And then we have the color. And then build. Build dot unwrap. Is it unwrap? Unwrap is for results. And this returns a result. Yes. Okay. So unwrap. And then we'll just store the mesh there. So we'll create the new ocean, and then we need to draw the ocean out. But we have the mesh, so we'll just make this public. And then we'll just draw the mesh starting at the left, wherever it is. Okay, so mod ocean. Use the ocean. Let's store the ocean. And we'll just create, we need the rectangle for the ocean before we can create it here. So that's going to be a new rectangle. So what is that? Graphics. I should change this in our snippets to like be the cleaner method. Okay, so we know that we want this to start at 0.0. Halfway down the screen, so this is going to be our arena height divided by 2. Our width is going to be the entire width of the screen, the arena width. And then the height is going to be the arena height divided by 2. I can actually just throw this directly into here. That wasn't too bad. And we don't need you. Okay, so we got a ocean, no semicolon for you. And then in draw, let's draw out. So graphics, draw. We have our context, reference to self.ocean, and our point. I guess like point to new, and we don't need to set this anywhere. I think that should be it for drawing our ocean out. What did I miss? The trait graphics drawable is not implemented for ocean. Oh, it wouldn't be ocean, it would be ocean.mesh. Okay. We still have an error. Oh, build takes context, which means we do need the context here. Do we have that? I do not. And you need to be a mutable reference. Oh, I put you inside the rect. Nope. You need to go in here. Okay, I think that will do it. All right, no more errors. Okay, so we have our ocean. And we can see the balls through the oceans. That's perfect. So I'll just leave you here. Let's update our README. We created the ocean. Okay, give the ocean fluid resistance. which is a magnitude of mover squared. Okay, so our ocean, we're going to have a resistance. So we have times the coefficient. So we have the resistance coefficient, which is an F32. And this is just something we make up. Like, I don't know, 2. And then we're going to, the force for this is going to be the magnitude of the ball's movement, so their speed. So speed squared times the coefficient. And the speed is the velocity. And the ocean should be the one applying the force. So pub function, I guess this is going to be like resist, resist mover. I don't actually know if we need it to be mutable self. Let's just try a reference to self. We need a mover that we're going to do. Good morning, Danny. Viva la resistance. Yes. Okay, so we're going to resist the self. We're going to have the mover that's coming in. This is the mover. And this is going to be probably like a mutable reference to, we need to bring in the circle. So I think this is going to be use create ball. So this is a mutable reference to a ball. And I think that's it. We don't return anything. We need to now calculate what this resistance force is. And we know that's going to be the magnitude of the mover squared. So that's going to be the ball dot velocity. Oh, it's going to be mover dot velocity dot magnitude. I don't know if it's magnitude or mag. I think this will work. This will give us, oh, it's private. I could also like get, have like a get speed function. That might be good to have. So public function speed. So just reference to self. We're going to turn an F32. I'm going to say self dot velocity dot magnitude. That's what we're returning. And so the ocean, we're just going to get the speed. So mover dot speed times mover dot speed. So we need this twice. And then we multiply that by the coefficient. Times self dot resistance coefficient. And so that's going to give us a resistance as a force. And then we're going to say mover dot apply force resistance. Oh, the delta time. So we'd want that too. I have no idea if this is a good idea. Resistance, mismatch types. Oh, this is an F32. So we need to turn this into a. We need to turn this into a direction also. There's more to this that we need to figure out. So here it is. That's our formula. Oh, okay. So drag, like this is the drag magnitude. Right, the force is going to need to be the opposite direction. So if we take a look at this, we have our drag. It gets a copy of the velocity. It multiplies it by -1 to get the opposite. It normalizes it, and then it multiplies this drag magnitude. So this is the resistance. It's an F32 though, so we also need to turn this into a vector too. So resistance force is now going to be because yeah, this is drag mag. Oh, we're just going to multiply it. So I don't need to turn that into the yet. We need to normalize it and then multiply it. So we need to get, I guess I'll just call it drag for right now. I'm not really sure exactly what else I would call it. But I do need to get the velocity. So this does need to be public. So drag equals the mover dot velocity times -1 dot 0. And then we're going to normalize it. Let's just mutable. Mute this. So we normalize it, and then we multiply this. So drag times the resistance. And now we can apply the force to this. And it's going to be drag that we're applying. I think that'll work. So now we come back to our main library and in update, for each ball, we update the ball, we bounce the ball, but now it's also say self.ocean.resist mover. We pass in, I think, a mutable reference to the ball and the delta time. Wait, it's mutable there. Wait, can I just pass in the ball because it's already mutable? Oh yeah, I can. All right, let's see if I got it. So they're slowing down a lot. I think that my coefficient can be a lot higher. So remember we had like 20. So let's say I do something in really huge. Let's see if this works. I mean, it does work. Am I applying the friction only in the ocean or always? Yeah, so I'm applying this drag in the ocean. I think it could be higher than that. I have a feeling that my delta time just screws everything up. Also, 1,000. Let's try it. So let's go to the ocean. We'll set this to 1,000. Oh, you know what? I'm applying it all the time. That's a problem. So this is like constantly applying the what is it? The drag from the ocean to the ball, because it's just resisting the mover here. I need to check first to see if the ball is inside of the ocean. So we're gonna need to do a quick check. So let's say in ocean, let's have another function here. So pub function is inside. I mean, I kind of want to just make this back to ball instead of mover. So we're gonna have a ball. We're gonna have this be a mutable reference to the ball, and we're gonna return a Boolean. And so we're gonna return that the ball.location.y plus ball.mass. So if that is greater than self.location.y, that's all we really care about, then that's a true. Oh, unnecessary parentheses. Oh, right, because I don't need those. Oh, you know what? The parentheses need to go here. That's where the parentheses need to go. Okay. So then in main library, we'll say if self.ocean.is inside, hand it the ball. If it's inside, then the ocean will resist the ball. Otherwise, it won't. Yes, Nikito, you were right. It was being applied outside the ocean. So hopefully now it will be not. And look at that. So they all fall really fast. They hit the ocean and bam, they slow down, but they all slow down at different speeds, depending upon how fast they're moving. So that's pretty cool. So that is fluid resistance. A reset button for this would be actually really nice. But I think that looks pretty cool. And then give the ocean fluid resistance. There we go. I'm going to go ahead and push up all of this code. So I guess example 2.5 fluid resistance. I'm going to push that up. So there's some cool things we can do with the ecosystem with this. We can put some areas in where there's going to be fluid resistance in, and then that will like slow creatures down when they go into it, which will probably take more effect later on when creatures can be really smart about things. And then I'm gonna share. Here's where this code is. It's in my Nature of Code in Rust repository, and I'll share that with you all here. So you can go take a look at the code. In the meantime, do I have any? Okay, so no issues worked on. It's 7:56. We got like 15 minutes. We can think about what we did that we might want to like add issues in here for this. So one issue that Danny, you brought up, there was a PR to review. I didn't see, did I not see it? No open PRs right now. Katali, who is doing his homework right now, but he is working on the create mesh wrapper for circles. So one thing is, do we want to wrap around GGEZ? I'm not sure we do for this library. Just re-export GGEZ in this library? Oh, interesting. Okay, so just make it available and so that we only pull in this. Okay, so we can create a discussion here maybe to chat about that. Kind of like how GGEZ re-exports an algebra and some other crates. Okay, that could be interesting. And then instead of like utility, we would potentially do those other things. Okay. Other issues for that we created. Let's look at our code for this. Well, so we create the configure, so like something to auto create the window mode for us. Like to auto do this for us would be really nice. Because this is a lot of boilerplate code. We can like maybe pull something in and just like it auto configures. So a wrapper around configuring the game. And it just has to return a new game. It has to return a game, an event loop, and context. So I guess let's start by like wrapping around window mode and window setup and building the context. So if we wrap around these three, then we can create something all together that uses all of those, and then we'll just call it and it'll hand us back. And we don't even need to hand anything back. We could just say, okay, well, this is the title of it. Here's who it is. And it just runs. We need the game. Yeah, so we need to hand it in the game and do that. Okay, so I like that. So create wrapper for running the game in the main .rs file. Currently, and the library take care of creating and running the game. So if I was to build this myself, what I might do is, instead of pulling in like ggez here, we'll just say use bbegz bring in the utility. This is where like we need do we need the utility new, or would this be something else? It's like maybe not utility in here. Maybe this would be like the actual game, or like run game. I don't know. We'll have to figure out what that should be. And then in here, we need the title. So what would this look like? It would basically be run game like start. We need to pass it in this like the game. Probably okay, so pass it in the game. It'll could get consumed by that, but that's fine. It's not being used by anybody else. The title. The name. So Zerker. And I think that would be it. And maybe like not game.start, game.like-run. And then we could have maybe an unwrap because it returns a result. I mean, I guess it could be sort of like this. We'll have the run here. So this could be run game. What was this before? This is just, oh, event. Okay. So run game. Or like engine, I don't know. We'll have to figure out that. Like that. BBG run, pass it. We don't need to pass the context because it'll figure that out. We don't need to pass it the event loop, it'll figure that out. We just need to pass it the game, the title, so this. And then we'll have these errors, like handling the error or just exiting out. And then that would be our main. What do you all think about something like this in our main function then? Would I be missing anything that I want to handle? What do we think about this? So I'll create that as an issue. We can maybe like hash through this before we like put the Hacktoberfest label on it. That would be really interesting to sort of wrap around it and just make it so that we could start running things on it. We don't have to have like nothing but utility structure on it. We'll have a lot of other structures in there. Yeah, and so Danny, I like your idea too. Let's add that as a new issue too as well. So re-export GGEZ from the library. That way we don't okay, so bringing in the wrong version and so I think we can do that. This one can definitely be a Hacktoberfest. Would this be a good first issue? I'm not sure. It might be. But then again, if you're not used to like how crates can work, I'll just do Hacktoberfest for right now. Let's see, what else did we have? So I'm going to revert you. Actually, I could just save you and then revert. That'll be easier. In our main library, I mean, right now I didn't really need to reuse the library, and so I didn't need to like keep it around. So that's something that's really interesting to think about. Is do I really need to keep it in the struct? Probably later on if I want to use those functions again. We could have like a gravity, like an entity, and then the entity you store you store meshes on it. And so like instead of us having to create, okay, here's a ball. What if I were to just say, okay, you're just like some entity. It's created in this this other library that we have. It's going to have like a location, a velocity, an acceleration, a mass, and a mesh. And so when it gets created, we just hand all of these things over to it, and then it has all of these standard functions on it, which then we can choose to call or not call. Right now we've got like very simple simple shapes that we've been using, just like circles and rectangles. And I think that's fine for what we're doing right now. Most of the games that we would make would probably be the same thing. Like things I'm thinking about are like the old arcade games. Sprites would be interesting, but I would probably still do rectangle shapes for them, and then just be a very naive shape. So that might be really interesting to try out. So create an entity structure. I guess like generation, entity structure. So we'll create that. We often use very similar so each challenge all struct. Okay, so what would this look like? We would want so where was this? This was chapter 2.5 fluid resistance. So what we would want on it I mean, so obviously like the base structure. A location, a velocity, an acceleration, a mass, let's see, a mesh, so we'll create the new, okay, so that's fields, and then let's see, generator function, or maybe I should just call it new function. How about just functions? We have new, we have apply force, I think move instead of update. So apply force, move, bounce would be really interesting. I'm not sure exactly how we want to implement that because we want to also say like bounce off which walls. So bounce and like get speed. So new, move, apply force, bounce. So like maybe that's a sign that it shouldn't actually be part of this this entity. That should be part of like the other library. Maybe a utility function then for that. Apply force, we want then like get speed. And I don't know what else we would want in here right now. So I'll just create this. For each of these, we could have a conversation about what it is that we want to like actually have. But I think that's where I'm gonna stop right now. It is 8:17. It's a couple minutes past when I normally end the stream. And I've got to go get ready for work. So I don't think there's anything else in here. I gave you guys a link to the code so you can go and play around with that. Next time we'll look into whatever the next nature of code is. This is a library that I'm using, and I'm going to continue using this all. So I will give you a link to this. I am for Hacktoberfest. I am accepting pull requests. I'll be accepting it for after Hacktoberfest too. But during the streams, after I go through the challenge, I'll look through the library, make sure there's no pull request to sort of update or comment on, and then pull those in. And I think it'll be a sort of a good cadence for us to go back and forth with that. And we can all get our t-shirts, and at the same time, we can improve the stream and get all of our code working together. All right. Well, with that, my next stream is planned for Friday morning at 6:45 a.m. Mountain Time. And that's it. I hope you have a great rest of your Wednesday, and I'll see you next time.